Video we will solve the remaining questions of GATE 2025 AC. In this question they have given that GM of each transistor is 5 milliseconds, and they have given the bias point as 2.5 volts each, and the sine wave is applied here with 10 millivolts amplitude. Similarly, a sine wave here is applied in 180 degrees phase minus 10 millivolts sine omega t, and they have asked to find out the node potential V3. We have to find both quiescent node voltage and small signal gain also. We can clearly see that 2 milliamps of tile current is flowing, so 1 milliamp each will flow in M1 and M2 because they have same VGS. Because of the symmetry, 1 milliamp each will flow in M1 and M2, so 1 milliamp will flow through this 1 kilo ohm resistor. So the voltage drop across this is 1 volt. So V3 DC is nothing but 5 volts minus 1 volt, that is 4 volts. When it comes to small signal equivalent, as we know, I'll draw the small signal equivalent. This node will be AC grounded. Here we have Vi sin omega t and Rd. This will be grounded, DC will be grounded, and this is V3. And when we replace this with the small signal equivalent, this will be a current source of value GM VGS. Here VGS is Vi and the resistance is Rd, that is 1 kilo ohm. This is ground. So V3 is nothing but minus GM VGS into 1 kilo ohm. VGS is Vi. V3 is GMS 5 millisiemens. 5 milli into the amplitude of input is 10 millivolts into 10 milli into 1k resistance, that is minus 50 millivolt. So the answer is option D. The DC voltage is 4 volts and the small signal voltage is minus 50 milli. In this question they are asking the values of R1 and R2. It is given that VEB2 is 0.7 volts, VEB1 is also 0.7 volts, and IZ is 25 milliamps and IL is 12 milliamps. IL is nothing but IC, that is 12 milliamps. From this we can find out IB. IB is nothing but IC by beta, 12 milliamps by beta is 120, that is 0.1 milliamp IB. So IE will be beta plus 1 times of IB, 120, 1 into 0.1 milliamp, 12.1 milliamps. IE is 12.1 milliamps. So the current flowing in R2 is 12.1 milliamps. To find out the value of R2, we should know this potential VE. If we know this potential, we can find the value of R2. We know the current flowing is 12.1 milliamps and the supply voltage 20 minus VE1 by R2. To find out R2, we should know VE1. We have 0.7 volts drop here, VEB2. So this node potential will be 19.3 volts, and it is given that the Zener voltage is 5 volts. Here we have 19.3 volts, 5 volts drop across Zener diode. So here it will be 14.3 volts, and VEB of Q1 is 0.7 volts. So this node potential will be 15 volts. So R2 will be 20 minus 15 by 12.1 milliamps, that is 5 by 12.1 milliamps, 5 by 12.1, which is 413.22 ohms. And we have to find the R1 value. For R1, the current flowing in R1 is IR1 is IB plus IZ. IB is 0.1 milliamp plus it is given that IZ is 25 milliamps. It will be 25.1 milliamps. So R1 is 14.3 volts by 25.1 milliamp. That is 569.72 ohms. If we round off this values to nearest integers, this will be 0.6, and this will be 0.4, and this will be 0.6 k kilo ohms, 0.4 kilo ohms. So the answer is A. And here in this problem, it is a 4-bit weighted register DAC. It is given that the input is changed from 1110 to 1101. This is 14 in decimal. This is 13 in decimal. 2 power 3 plus 2 power 2 plus 2 power 1 plus 0 is 8 plus 4 or plus 2, 14. Similarly, this will come out to be 13. In weighted DAX, the resolution is how much the output match the output changes for LSB. Here LSB is 1 for 1 bit change. If we change the LSB, that is, if we make B naught as 1, this will be connected to this, and the Vref is 2 volts, and the current of 2 by 8R will flow in this direction. 2 by 8R current will flow. V naught is nothing but minus R times of 2 by 8R minus 1 by 4 minus 0.25 volts. Here resolution is minus 0.25 volts. So the input is changed from 14 to 13. So it is a 1 bit change. So the magnitude will change by 0.25 volts. So the answer is 0.25 volts. In this question, it is given that a input of 10 sin 100 pi t is applied to the circuit, and we have to find out for how much time the diode will conduct in a single period. If we plot the input voltage Vi 10 sin 100 pi t, here omega is 100 pi, so t is 2 pi by omega, that will come out to be 1 by 50 seconds. So this is a single time period t, the duration is t, and diode conducts when Vp is greater than Vn. Let us say this P junction voltage is, P side voltage is Vp, this voltage is Vn. If the potential difference between these two is positive, then the diode will conduct for an ideal diode. For this to conduct, this node potential is tied to minus 5 volts. So Vp has to be greater than minus 5 volts. So if we look here, in this 1 period time, the input is higher than -5 in this region and in this region. So in here the diode will conduct. Diode is on here in this area and in this area. And this area is T by 4th. In this area the diode is off because the voltage is less than -5 volt, so this will be off. The total on period is 3 by 4th of the time period. So here time period is 0.02 seconds and the T on will be 0.015 seconds. The answer is 0.015 seconds. And the last question is this one. Here we are varying the input from -m to m, and we have to check which of the plots are correct. We'll divide this into two parts. One part is -m to 0, the second one is 0 to +m. If the input is -m, the current will flow in this path. These two diodes will conduct D1, D3, let us say D2, D4. D1, D3 on, because it is a negative potential and this is positive than this, so Vp will be higher than Vn for this diode. This will conduct. Similarly, this diode will conduct. So this is -Vm volts and resistor R minus plus V0. Clearly we can see V0 is minus V1, that is minus of minus Vm, which is Vm, and the current I1 is V1 by R. V1 is minus Vm, so the current is minus Vm by R. In the second case, 0 to m, the other two diodes will be on. These two diodes will conduct. The current direction will be this, so the circuit will be like this. Plus minus V1 equals to Vm. Here the current is flowing from positive terminal to negative, so this is plus, this is minus R, and the direction is same, V0. Here V0 is Vm, I1 is Vm by R. In the first case, the current was flowing from negative terminal of resistor to positive terminal, so V0 potential is negative of the input voltage. Here it is in the same polarity. So from these plots, this is true, this is not correct, because in both uh, uh, half cycles V naught is Vm. So first option is correct and this is not correct because it has negative values here. And I1 in the first half is negative minus Vm by R. So this plot is correct. A and D are correct. Okay, thank you.